Let's go back to the diffraction grating. We just came up with the formula. What was the formula that we just came up with? Here, d sine theta is equal to n lambda. What is d?
D is the distance between
the two slits. What is lambda? Lambda is the wavelength of the light coming in. And what's n? N is which maxima is being produced. Right? That's important, eh? N is which maxima is being produced. You will see it a little more, you will see it a little bit clearly now in the other example. Right? So yeah, so we came up with this formula, d sine theta equal to n lambda, and I showed you an equal to n lambda. That was really because we're producing maximas, right? Everybody okay with that? Right, then let's see what the next exercise says. What's that? That's 4, 5, 6. It says that thus, right, if the light from all the slits is brought to a common focus, that each slit interferes constructively with that from every other at those values of theta given by equation 26.2, the effect of the grating, therefore, is to produce a series of bright images known as principal maxima. That's okay? And the angular position theta, which are given by the equation, right? That's the same equation I was now talking about, right? The sine theta is equal to n lambda, right? Each value of theta applies to either side of the normal, right? And I will show you what that means just back. Let me show you one time. If you look here, right? So the value of theta is here. When n is 1, that's the theta 1 value. When n is 2, that's the theta 2 value. But it also applies to down here. Okay? So if here theta 1, same thing will happen down here. You would recognize that n1, the n1s are the same distance away from n0. The n2s are the same distance away from the n0. That's okay? So all the thetas are measured from n0 to the rate. Right? So that is theta 2. Here, that's theta 1. That's okay? So when they say n is 1, we'll use the word order. When the order is 1, this is what we're referring to. And the angles for that is here. When they say the order 2, that's from here to here. Okay? And that will be the angle, right? The angle is always from n0 or what we call the normal. N0 is the normal. Okay? Everybody okay with that there? Online? Are you okay with that? Right? So thus, if the light from all we that's already, right? It can be shown that a grating which has a large number of slits produces what can be considered to be a completely destructive interference in all directions, other than those given by 26.2, and therefore gives rise to very sharp principal maxima. Right? So all they're saying is that what is making the principal maxima sharp is when you have all the dark in between. Think about it. Bright will only show up if you have dark around it. And so look at this, look at what I have here. You'll see this, the fringe here, right? But if I remove the dark, remove my fingers, you'll see it, No. But if I put something to contrast around it, you'll see it, right? So that's kind of what they're saying, right? What they're saying there is that if you have those completely destructive parts, it'll be very easy for us to see the principal maximums. All right? The zero order principal maxima, that's when n is 0, is given by the equation as having an angular theta value of 0 for all the values of d and lambda. The position of the first order, n is equal to 1. Second order, n is equal to 2, etc. Principal maximus, however, depend both on d and lambda, which should be obvious, right? If you have the formula d,
Excuse Vinay, please come up to the office.
if you have that formula there, right? If you have d sine theta equal to n lambda and n is 0, then y dependent on nothing really, right? But if n becomes 1, then sine theta is dependent on lambda and d. You're saying that? So that's what they're saying. They are saying that all the other principal maximas are dependent on d and lambda. Right? When n is 0, it's not dependent on anything. Right? But all the others dependent on that. Right? A typical grating is 1/600,000 meters. Right? That's the value of T. If such a grating is illuminated by light of that wavelength, then when n is 1, determine the angle. So what it's telling you there is that if it is illuminated by this wavelength here, when the light is grated, this is n0. n1, which is here, n1 will be 21.1 degrees away. And 1 underneath here will also be 21.1 degrees away. That's okay? And how far will n2 be? How much degrees? N2 will be 46.1 degrees away. That's okay? And we can find n3 and n4, but something really interesting will happen as n gets too big. And we'll see it just now, right? But, right here. But when n is equal to 3, sine theta is 1.08. So we'll work out that come on. Let's use the same value. So go take calculator. Go take calculator. D sine theta is equal to n lambda. And when n is 3, do my favor. Use this formula and tell me what you're getting for sine theta. So plug in n is 3, plug in d is 1/6,000, and plug in lambda is 6 by 10 to the minus 7. And tell me what you're getting for sine theta. Sine theta equals something. Then we have a calculator. You have a calculator? 6 times 10 to the minus 7. Yeah, we're climbing a little way. While coming up on number 4. What you all getting? 1.08? Right. Now find sine inverse of that. Let's see what angle we'll get with theta. Alexis, where you get it? When you find sine inverse of 1.08. Make sure you calculate in degrees, huh? Error? Serious? Why again error? Very calculated. It's supposed to get the error.
Yeah.
Right? So the error is good. Here's why. Right? Number 1, sine theta can never be bigger than 1. Right? That's number 1. The next problem is here's what happened. Let's pretend we use the last example. Here's 21. Here's like 47. But N3 giving you an angle that is, what's the largest angle that can be formed here or there? What's the largest angle that could be formed here? Okay, let me ask a different way. Suppose the angle was 90 degrees. Would you see it on this screen here? Right, so the largest angle is anything less than 90. 89.99999, we can see it. Right? So here's what it's saying. It's saying that entry not being formed here cannot be formed then because the angle is too big. So basically, entry doesn't exist for this diffraction grating. Right? That will happen. Right? Some will be you'll be able to read off N1, N2, but N3 might not happen. Sometimes not even N2 will happen. Not even N2 will you'll be able to record to see N2. That's okay? Right? So here what that means. That means that there's a maximum number of principal or N values that we could get. There's a maximum number of N that we could obtain. What's the formula again? D sine theta is N lambda. Right. I want us to find a way to determine the largest possible N value. You know, that goes to you since you're the number one match student here. Aaron, what's the largest values N could be? So here what you want to ask yourself. Would D or lambda affect theta? Okay, that's a bad question. What's the largest value for sine theta? Just say largest value sine theta could be as 1, right? And that corresponds to what angle? Sine of what angle gives you 1? 90. Sine 90 is 1. So here what I'm saying. What it says is that the largest value could only happen when theta is 90 or sine theta is 1. So it means that if the formula now becomes d n lambda or n is equal to d on lambda. So if you have to figure out your maximum number, right? If you have to figure out the maximum number of orders, the formula is n on lambda. Right? The maximum number of orders is d on lambda. You're saying that? You have to learn that, right? Do me a favor, for this question, divide d on lambda. Tell me what you get. Right? D was 1 on 6,000, 600,000, and lambda was 6 by 10 to the minus 7. What you get? Not around 2.7. Right? 2.78. So, what should they saying? What should they saying here? This is saying the largest possible order is 2.78. So when you round up that, what you will get? 3. So why it is this example saying n equals to 3 not possible? If we round it up in again 3. So why it is 3 not possible? Anybody? Why it is 3 not possible? It's saying 2.78 possible.
Because 3 is past 90.
3 is past 90. Right? And you do have orders in between, either a whole number or not. Right? So what do you do when you get the answer for maximum d divided by lambda? What you should do? Round up or round down? Round down. Right? Do you ever round up? Always round down. Okay? So write this as an example and write down we always round down. Never round up. Okay? Never round up.
So where the key to physics books on that?
Okay, so let you put this in the little cupboard that might think it could be there or we put it. Are you okay with that? Everybody okay with that? Analyst, you okay with this, yes? Right, if the grating is turned so that the angle, it follows that the number of orders can be increased by increasing D. Right, and you always see that, or reducing the number of lines per meter. Reducing the total number of lines decreases the sharpness, right? So those are little things that you can read off and learn as well, right? But it's said by reducing the total number of lines decreases the sharpness of the principal maxima, right? And also gives rise to faint line, subsidiary maxima in the region between the principal maxima. So again, you want to have a lot of lines, right? You want to have a lot of lines, a lot of patterns, you want them close together. Far apart, you'll mess it up, right? Your fringes wouldn't be as distinct or as intense anymore. Choose intense, they won't be as sharp. You okay with that? Let's see if we can put that right. Let's see if we could do this now. Actually, let's do the same question here. Look at page 457. Read it through to see if it makes sense. Once you understand that concept about maximum, one thing you can give it. Right?
Excuse, and Janaya, please come up to the office.
Right, take a little read there. Let's see how it's going to explain it, right? So it's three. I want to let me explain this first part. If you look at the grating there, right? The grating has 300 lines per millimeter, right? 300 lines per millimeter, and then they give you, well, second order, and it's 200 to give you the angle, the way you find the wavelength, right? So of course, you have to be able to rearrange your formula. But here's how we find D, right? And I want you to understand how we get D. Watch this here. So here what it's saying. This is saying that we have 300 lines in 1 millimeter. 1 millimeter is how much? 1 by 10 to the minus 3 meters, right? Right. What we need is we need to figure out how many lines in 1 meter. How you do that? Actually, let me leave this here. You can figure out if you have 300 lines in a millimeter, how many lines in a meter? How many millimeters in 1 meter? Peter? How many millimeters in a meter? 1,000. So you multiply by 1,000. So you'll get 300,000 lines in 1 meter. Right. When you reach here, you have to find for one line. So one line is a D value, which is 1 over 300,000. That's okay. That's how they got 1 over 300 by 10 to the 5. Okay. You need to find the thickness of one line. Okay. So you find how many lines in a meter, right? And then you divide everything by 10,000. 300,000 lines is 1 meter, so one line is 1 over 10,000. Right? So if you look here, the D is 1 over that, and the maximum order N is 2. So if you plug in N is 2, you plug in D and you plug in theta they give you, they give you theta here. Make lambda the subject of the formula. So again, all you had to be able to make the subject of the formula. That gives it to that properly, right?
Excuse, and Janaya, form 3, please come up to the office to sign out.
You can write it down. So you can see that right now. Okay. Well, could you all for this same question? Tell me the maximum number of orders. Work out the maximum number of orders possible here. Use their values, right? All of them for values. What's the maximum number of orders possible? How much you got, Soraya? Well, I suppose to wait then. Come on, I suppose to wait. But if I suppose to wait, what do we do? Wait. I just sit down and wait. Right, what's the maximum number of orders? Yeah, what you got?
I think I answered wrong.
What you got?
5.5 by 10.
If it's wrong. Tell me what's the formula? How do you find maximum number of orders? N is equal to what? D on lambda, okay, ma'am. What is D? No, ma'am. 1 over. Right. Oh, what else gonna say 3.33 by 10 to the, oh, okay. Well, do say that, right? And lambda is what? 5.4 by 10 to the negative 7. And when you divide it, how much you got? Exact value?
No, 6.17.
6.17. So the maximum number of orders is 6, because we always round down. That's okay? Check back your value, there and number. Alright, keep going down. Check it back. Put brackets around it and then. Remember, you can put that in a shit, you can put that in a class U, a fraction over a fraction. Check it back quick.
So what counts as if you're getting 10 to something, but is it the correct value back in there 10 to something?
Now, you just wait something wrong, you see?
Yeah, not necessarily.
No, bring it, you want to carry. I will show you. Everybody understand how to get 6? Families. I just why you sitting on this by yourself. But like, you know, I don't like it. No, because both equations is this 1 by 10 to the 5 over 300. Hold on. Ten to the 5 is underneath. Wait, in the wrong place. Right, so normally the target are giving you a mistake, I'll look within, but the mistake might be. So look. Are you okay with that? That's the diffraction grating. That's the concept behind it there. Alright? Can't open the door so hard. Right? What's the next one? What's the next one? What's number 2 I mean? Right? In number 2, they ask how many principal maxima are produced when a grating with a spacing of 2. All they do is just divide and they get 3.11. So the answer is 3. Easy, right? Right? Do me a favor. Go to the bottom of your page there on 457. And let's do do number 1 and 2. Those are to be honest, in past papers, it's not much different. Right? But here's what is we have, right? And then that way. In past papers, you have to figure out when to use diffraction grating and when to use the y is equal to d lambda. Right? I don't know which one to use. Here. I will know when to use d sine theta n lambda or when to use y is d lambda. I will know. The reader question, what are the key things you're looking out for? Both of them have wavelength. So yes, the part of the line thing is not a bad thing. Why is it looking out for all you? Huh? Hear me? You're looking out for angles, okay? Because the next one have no angles, right? But you're looking out for the obvious diffraction grating. If you see diffraction grating, d sine theta n lambda. If you do see it and you see fringes, most likely that has to do with y is d lambda on e. Okay, all right, go ahead. Do number 1. We'll pass, finish them already. Number 1 and 2 quickly. Okay. Everything we do in the book. Right? I gave you all 2 questions. Today we are going to add 1 more bit. I want to turn but I'm going to hand on Friday. And I'll come to on Friday. But too bad. We will do tomorrow. I'll check tomorrow. Might be here till tomorrow. Check. Right? Just do those 2 questions. And I'll give you 1 on this. And for next week, Monday, I want to read up on lenses. Right? Lenses, the last part of the hand. I'll give you more module 3 homework on Friday. After all the hand. Oh yeah, we bring it working here, I'm still working for number one. Finish? Hurry, guys, you need to go quick. How much time, I have to do one and two. Take care, write a note to bring journals tomorrow. Whatever you haven't. So you come tomorrow? Come tomorrow. Bring a journal tomorrow. Right, just in case others struggling to make it subject to the formula. Remember you have d sine theta is n lambda. So theta is carry across the d, you divide, carry across sine, you get sine it. Right? So the set for first order means n is what? 1. Second order means n is. So this will be what's lambda? Lambda is 5.7 by 10 to the minus 7. And they give it d on a grating with a space in here. They give it d already. D is 200, sorry. D is 2 by 10 to the minus. When you work it out, what you got potato? 16? 16.6, right? And then do it again for the second order. Just change the 1 to the 2. What are you confused about, Annalie? What are you confused about? Annalise, I mean. Nothing? What are you confused about with Vanessa?
It was just something getting from it, I think.
Oh, here, what are you confused about? Oh, something very. Optically form. But again, see the two. Huh? Have it smaller, I'll be bigger. 34.75. I remember two significant figures, right? You get on this? Do number two one time. Do number two number two one time. Double, what are you talking about? Because kid talking to you, you gotta talk. You're rude to, Next one, 10 over 2 fast. Wait, well, I check number 2, but when you finish, you'll come back over this, right? That's not good.